And now in this lecture we'll answer 2 questions. In the first question we'll find out the length of this tangent MF is equal to x. In the second question we'll find out the length of this tangent AP, this is also equal to x. So we'll start with the first question. In the drawing we have 3 identical circles, and we have this big tangent ABC. The big tangent ABC is tangent to this circle at point A, is tangent to the middle circle here at this point B, and tangent to this circle at this point C. In addition, we have, this is the current standpoint, point M. From this current standpoint, point M, we have tangent MD that is equal to 5 units in length. Tangent MD is tangent to this circle at point D. In addition, from the same current standpoint, point M, we have tangent ME that is tangent to this circle at point E. The length of tangent ME is 7 units. And finally, we have also tangent MF that is tangent to this circle at point F, and the length of tangent MF is x, and our mission is to find out the length of tangent MF that is equal to x. So we have to find out the value of x. So first of all, we define the center of this circle. This point is point P. We define the center of this middle circle. This point is point Q. And finally, we define the center of this circle. This point is point S. In the next step, we'll join points P and D together by straight line. Point P is the center of this circle. Point D is a point on the circle itself. Therefore, PD is the radius of this circle. We'll define the radius of this circle as R. So the radius of the other 2 circles must be also equal to R because of the fact that the 3 circles are identical. And here we have the radius PD of this circle. The radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle. And whenever you have radius that is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we'll join points M and P together by straight line. When joining points M and P, we created the right triangle MPD. So, in the next step, we'll implement the Pythagoras theorem on this right triangle MPD. According to the Pythagoras theorem in the right triangle MPD, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. The hypotenuse in this right triangle MPD is MP, and therefore the square of the hypotenuse is MP square, and MP square must be equal to PD square plus MD square. So again, in the right triangle MPD, according to the Pythagoras theorem, MP square, that is the square of the hypotenuse, equals to PD square plus MD square. MP is the missing side, so we leave it as it is, so it is MP square and it is equal to PD square. PD is R, it is the radius of this circle, therefore PD square is R square plus MD square. Tangent MD equals to 5 units in length. MD is 5, therefore MD square is 5 squared, that is 25. So in total, according to equation 1, we actually found out that MP square equals to R square plus 25. We repeat on the same process on this middle circle. and we'll actually join points E and Q together by a straight line. EQ is of course the radius of this circle that is equal to R, and because of the fact that the radius QE that is equal to R, the radius QE is drawn to point E, that is the point of tendency of tangent ME with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and Q together by a straight line. By joining points M and Q, create the right triangle MQE. So in the next step, we will implement the Pythagoras theorem on this right triangle MQE. According to the Pythagoras theorem, MQ squared, that is the square of the hypotenuse, equals to QE squared plus ME squared. And again, in the right triangle MQE, according to the Pythagoras theorem, MQ squared equals to QE squared plus ME squared. The hypotenuse MQ is the missing side, so we leave it as it is, so it is MQ squared equals to QE squared. QE is R, therefore QE squared is R squared plus ME squared. The tangent ME equals to 7 units in itself, therefore ME squared is 7 squared, that is 49. So in total, according to equation 2, we actually found out that MQ squared equals to R squared plus 49. So based on the same process of this right circle, we join points S and F together by straight line. SF is of course the radius of this circle that is equal to R, and because of the fact that the radius SF is drawn to point F, that is the point of tendency of tangent MF with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and S together by straight line. By joining points M and S, we create the right triangle MFS. In the next step, we implement the Pythagoras theorem on this right triangle MFS. In the right triangle MFS, according to the Pythagoras theorem, MS squared, that is the square of the hypotenuse, is equal to SF squared plus FM squared. And again, according to the Pythagoras theorem, in the right triangle FSM, MS squared equals to SF squared plus FM squared. The hypotenuse MS is the missing side, so we leave it as it is, so it is MS squared equals to SF squared. SF is R, therefore SF squared is R squared plus FM squared. FM equals to X. That is the tangent that we are looking for in this question. So Fm equals to X, therefore Fm squared is X squared. So in total, according to equation 3, we found out that MS squared equals to R squared plus X squared. In the next step, we will join points P and A together by straight line. So actually, PA is of course the radius of this circle that is equals to R, and because of the fact that the radius PA is drawn to point A, that is the point of tendency of tangent ABC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius PA. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we join points Q and B together by a straight line. QB is of course the radius of this circle that is equals to R, and because of the fact that the radius QB is drawn to point B, that is the point of tendency of tangent ABC with this circle, and whenever your radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. And finally, we join points C and S together by a straight line. CS is of course the radius of this circle that is equal to R, and because of the fact that the radius SC is drawn to point C, that is the point of tendency of tangent ABC with this circle, and whenever your radius is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius CS. If ABC is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So the 3 points P, Q, and S that are the centers of those those 3 circles, the 3 points P, Q, and S are all located at the same distance from the from tangent ABC. Again, from the straight line ABC. Again, the 3 points P, Q, and S are all located on the same distance of the straight line ABC. The distance between point P and the straight line ABC is R. The distance between point Q and the straight line ABC is also R. And finally, the distance of point S from the straight line ABC is also R. And therefore, first of all, the 3 points P, Q, and S, they must be located on the same straight line. That is to say, PQS is one straight line. Moreover, because of the fact that the 3 points P, Q, and S are all located on the same distance from the straight line ABC, it means that the straight line PQS must be parallel to the straight line ABC. Again, because of the fact that the 3 points P, Q, and S are all at the same distance from the straight line ABC, therefore the straight line PQS must be parallel to the straight line ABC. And because of the fact that the straight line PQS is parallel to the straight line ABC, we can implement here rule 17. So I repeat quickly on rule 17. According to rule 17, the sum of one-sided interior angles between two parallel lines is equal to 180 degrees. So in the drawing, we have line A is parallel to line B, and line C, the red line C cuts the two parallel lines A and B and those 2 points. And in addition, we have here those 2 angles 2 and 1. Those 2 angles 2 and 1, they are both defined as one-sided interior angles. First of all, they are one-sided because of the fact that both of them, they are located on the right side of the red line C, and because of the fact that both of those 2 angles are located between the parallel lines A and B, they are also defined as an interior angles. So in total, those 2 angles 2 and 1, they are defined as one-sided interior angles. And according to this rule, rule 17, the sum of 2 one-sided interior angles is equal to 180 degrees. That is to say, angle 2 plus angle 1 is equal to 180 degrees. Likewise, those two angles, beta and alpha, they are also defined as one-sided interrogants for the same reason that those two angles are also defined as one-sided interrogants. And according to this rule 17, the sum of two one-sided interrogants is equal to 180 degrees. That is to say, beta plus alpha is equal to 180 degrees. So we can actually implement rule 17 in our drawing. Why? Because in our drawing, those two angles, they are both defined as one-sided interrogants. And because of the fact that they are located between the parallel lines PQS and ABC, the sum of those two angles must be equal to 180 degrees according to rule 17. So this is a right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interrogants. And according to rule 17, the sum of two one-sided interrogants is equal to 180 degrees. So this angle equals to 90 degrees plus this missing angle. In total, they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interrogants, and they are located between the parallel lines PQS and ABC, and therefore the sum of those two angles must be equal to 180 degrees according to rule 17. So this is a right angle plus this missing angle. In total, the sum of those two angles is equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interangles because of the fact that they are located between the parallel lines PQS and ABC. The sum of those two angles must be equal to 180 degrees according to rule 17. So this is a right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. So, inside the quadrilateral QSCV, inside this quadrilateral, we have four right angles. And according to rule 5, any quadrilateral that has four right angles must be at its left angle if not a square. So, related to this quadrilateral QSCV is a left angle because it has four right angles. Okay, so this quadrilateral QSCB is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle SQBC, the opposite sides must be equal to each other. So side BC must be equal to the opposite side QS. But BC is 3 according to what is given as the equation, therefore QS must be also equal to 3 units in its length. Likewise, according to the same rule, in the same rectangle QBCS, the sum QB must be equal to the opposite side SC. Okay, so actually we don't need this. Actually, we already know that QB equals to SC equals to R. So here, in quadrilateral PQBA, we have four right angles, and according to rule 5, in quadrilateral that has four right angles must be this left angle if not a square. So relate to this quadrilateral PQBA is a left angle because it has four right angles. But you also know that the opposite sides of a left angle are equal to each other. So a left angle PQBS, side AB must be equal to the opposite side PQ, but AB is 3 units in its length, according to what is given in the question, therefore the opposite side PQ must be also equal to 3 units in its length. In the next step, I'll copy the big triangle AMS. In the equation, we analyze this big triangle AMS. This is actually triangle MPS. This is triangle MPS. So actually, this is triangle MPS that I copied from the original drawing. PQ equals to 3 units in its length, according to what we've already found out. And QS also equals to 3 units in its length. Yeah. QS equals to 3 units and PQ also equals to 3 units in its length. The red line segment MQ is the median of this triangle MPS. So write it down. This is the median of this triangle MPS. So the median of a triangle starts from the vertex of the triangle and ends at the midpoint of the opposite side PS. The midpoint of the opposite side PS is Q. Why Q is the midpoint of PS? Because of the fact that at point Q, side PS has been bisected into two halves. The first half is PQ, that is equals to 3, and the second half is QS, that is also equals to 3 units in itself. So the median MQ in a triangle bisects the opposite side into two halves. It starts from the vertex and bisects the opposite side PS into two halves. In this case, each half equals to 3 units. PQ equals to QS equals to 3. Okay, but the question is, what is the length of the median MQ? Actually, we have a special formula for the length of median on a triangle. Actually, you can do the same thing at the vertex P. From the vertex P, we can draw a line segment that ends at the midpoint of MS. That is to say, the median will from the vertex P will bisect side SM into two halves, and you can also draw the median from point S to the midpoint of MP. So any triangle has 3 medians. So median MQ is the median to side PS that bisects side PS into two halves. So what is the length of the median MQ? So we have a special formula for the length of median in a triangle. So in the drawing we have triangle ABC. This is triangle ABC. The length of side AB is B units, side AC equals to C units in its length, and side BC equals to A units in its length. In this triangle ABC we have the median AD. The median AD exists from the vertex A and ends at point D, that is the midpoint of BC. Why point D is the midpoint of BC? Because of the fact that at point D, side BC is bisected into two halves. Each half equals to BD equals to DC equals to BC over 2. So AD is the median of triangle ABC, which means bisect side BC into two halves. Each half equals to BC over 2. BD equals to DC equals to BC over 2. So what is the median? What is the length of the median AD of this triangle ABC? According to the new formula, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. Again, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. AB is equal to b. The length of AB is b units, the length of AC is c units, and the length of side BC is a unit. So the median AD equals to the square root of 2b squared plus 2c squared minus a squared over 2. We can actually implement the new formula in order to find out the length of this median MQ. So according to the new formula, the length of the median MQ will be equal to the square root of 2mp squared plus 2ms squared minus ps squared. Okay, minus ps squared over 2. Then again, according to the new formula, the length of the median MQ of this triangle MPS will be equal to the square root of 2pm squared plus 2ms squared minus ps squared over 2. Okay, so here we multiply this equation 1 by 2, and we get that according to equation 1, two times MQ equals to the square root of 2mp squared plus 2ms squared minus ps squared over 2. And again, according to equation 1, we should find out that we multiply this equation 1 by 2, and finally found out that 2mq equals to the square root of 2mp squared plus 2ms squared minus ps squared. So in the next step, we'll square both sides of this equation 1. So 2mq squared is 2 squared, that is 4, times mq squared. So 2mq squared equals to 4mq squared. So we squared also the underside of this equation 1, and because of the fact that the square cancels the root, we left only with what is inside the root, that is 2mp squared plus 2ms squared minus ps squared. So it is 2mp squared plus 2ms squared minus ps squared. So according to equation 1, 4mq square equals to 2mp square plus 2ms square plus ps square. So 4mq square. mq, according to equation 2, mq square equals to r square plus 49. Therefore, we substitute mq square here by r square plus 49. And it is equal to 2mp square. But mp square, according to equation 1, mp square equals to r square plus 25. Therefore, we substitute mp square here by r square plus 25 plus 2ms square. So it is 2 times ms square. ms square, according to equation 3, ms square equals to r square plus x square. Therefore, we substitute ms square here by r square plus x square. We have also minus ps square. ps in total equals to 3 plus 3, that is 6. Therefore, ps square equals to 6 squared, that is 36. So in total, ps square is 36. So it is minus ps squared, that is minus 36. So here we'll open the brackets on both sides of this equation, equation 1, and we get that four r squared plus 4 times 49 is 196 equals to 2r squared plus 2 times 25 is 50 plus 2r squared plus 2x squared minus 36. So in this side of equation 1 we have 4r squared, in the other side we have 2r squared plus 2r squared, that is 4r squared. So 4r squared will get cancelled. After we cancel 4r squared, in this side of equation 1 we left only with 196. That is equal. On the other side of the equation we left with 50 minus 36 is 14. So in total, in this side of equation 1 we have 14 plus 2x squared. So in total, according to equation 1, we can find out that 196 equals to 14 plus 2x squared. Here we subtract 14 from this equation, equation 1, and we get that, according to equation 1, 196 minus 14 is 182, so 182 equals to 2x squared. Here we divide this equation 1 by 2, and we get that 182 over 2 is 91, so 91 equals to x squared. So here we take a root out of this equation, and we get that x equals to the square root of 91. The square root of 91 is 9.54 units. So in total, we shall find out that the length of tangent MF, the length of this tangent MF that is equal to x is equal to either the square root of 91, or in terms of numbers, the length of this tangent MF is equal to x, it is equal to 9.54 units. Actually, it makes sense that it will be equal to 9.54 units because of the fact that we have here tangent ME equals to 7 units in itself. From the drawing it is very easy to see that MF is longer than ME. But ME is 7, therefore MF must be greater than 7, so it is 9.54. So in total we shall find out that the length of tangent MF that is equals to x is either 9.54 units or square root of 91 units. So we finish with the first question. In the next step I will present to you the second question, and we solve the second question of this lecture. The second question, our mission is to find out the length of this tangent AP is equal to x. We have to find out the value of x. So in the drawing, we have quarter circle A or B. Inside this quarter circle A or B, we have this small circle. The small circle touches the big quarter circle at this point. So we define their touching point, this touching point, as K. In addition, OB is tangent to this small circle at point Q. This is line segment OQ, that is equals to 5 units in Islam. Again, our mission is to find out the length of tangent AP that is equals to x. Tangent AP is tangent to this small circle at point P. First of all, we define the center of this small circle as C. And we join points C and Q together by a straight line. Line segment CQ starts from point C, that is the center of this small circle, and ends at point Q, that is the point of the small circle itself. So this is exactly the definition of a radius. Therefore, CQ is the radius of this small circle. We define the radius of this small circle as A. Therefore, CQ equals to A units in its length according to our definition. Because of the fact that the radius CQ is equal to A, the radius CQ is drawn to point Q, that is the point of tendency of tangent OB with this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. We join points C and P together by a straight line. PC is of course the radius of this circle, that is equal to A. And because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle APC. So I copy the right triangle APC in a new page, and we will implement the Pythagoras theorem of this right triangle, triangle APC. Here by PT is the progression for Pythagoras theorem. So actually this is the right triangle APC that I copied from the original drawing. This right triangle APC, according to the Pythagoras theorem, AC squared, that is the square of the hypotenuse, equals to AP squared plus PC squared. So I write it down, this will be equation 1. AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. AC is the missing side, so we leave it as it is. So it is AC squared equals to AP squared. AP is x. X is the number that we are looking for in this question. AP is x, therefore AP square is x square plus PC square. PC is x, therefore PC square is a square. So in total, according to equation 1, we can find out that AC square equals to x square plus a square. Because of the fact that the small circle touches the big quarter circle at this point C, so actually the small circle and the big quarter circle have an internal arch between them at point K. That is to say, they are touching each other internally at point K. And whenever you have an internal arch between two circles or semicircles, you can implement, or quarter circles, you can implement rule 9. So quickly on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects the centers together passes through their touching points. So in the following, we have two circles. The center of this big circle is here at point O, the center of this small circle is here at point M. The straight line that connects the centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. Again, the straight line OM must pass through point P, that is their touching point, or OMP is one straight line. Again, OMP is one straight line according to this rule 9. So we can actually implement rule 9 in our drawing. Why? Because in our drawing, we have an internal arch between the small circle and the big quarter circle. That is to say, they touch each other internally at this point K. The center of this quarter circle is here at point O. The center of this small circle is here at point C. And the straight line that connects the centers together is of course the straight line OC. This straight line OC must pass through their touching point, that is point K. Again, the straight line OC must pass through their touching point, that is point K. Or OCK is one straight line. Again, OCK is one straight line according to rule 9. So we join points O and C together by straight line, and according to rule 9, the straight line OC pass point K, that is your touching point. It's very easy to see from the drawing. The straight line OC passes through point K, that is the touching point, exactly according to rule 9. What is the definition of line segment CK? Line segment CK starts from point C, that is the center of this small circle, and ends at point K, that is the point of the small circle itself. So this is exactly the definition of a radius. Therefore, CK is the radius of this small circle. Is equal to A. CK equals to A. What is the definition of line segment OK? Line segment OK starts from point O, that is the center of the quarter circle, and that's at point K, that is the point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, OK is the radius of this quarter circle. So we define the radius of the quarter circle as B. Therefore, OK equals to B. What is the length of line segment OC? From the drawing, it is very easy to see that OC equals to OK minus CK. Again, OC equals to OK minus CK. So I write it down. OC equals to OK minus CK. So OC in total equals to OK. OK is the radius of the quarter circle, that is B. Minus CK. CK is the radius of the small circle, that is A. So in total, OC equals to B minus A units in its length. OC, this is line segment OC, is equal to B minus A units in its length. In the next step, I will copy the right triangle OCQ in a new page, and we will implement the Pythagoras theorem on this right triangle OCQ. Here by PT is the abbreviation for Pythagoras theorem. The hypotenuse OC equals to B minus A units in its length. OQ is 5 units in its length according to what is given in the question, and CQ is the radius of the small circle, that is A. So actually, this is triangle OCQ that they go back from the original domain according to the Pythagoras theorem. This right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. So write it down, this will be equation 2. So OC squared, that is the square of the hypotenuse, equals to CQ squared plus OQ squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equal to CQ squared. CQ is A, therefore CQ squared is A squared plus OQ squared. OQ is 5, therefore OQ squared is 5 squared, that is 25. So in total, according to equation 2, I shall found out that B minus A squared equals to A squared plus 25. B minus A squared is B squared plus A squared plus 2 times A times B, and it is equal to A squared plus 25. So here we have A squared on both sides of the equation, so A squared will get cancelled. After we cancel A squared, in this side of equation 2 we left only with B squared minus 2AB, and the other side of this equation, equation 2, we left only with 25. So in total, according to equation 2, we actually found out that B squared minus 2AB equals to 25. In the next step, we will do a construction, that is to say, from point C, that is the center of this small circle, we will draw perpendicular on AO. Again, from point C, we will draw perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point 10. By doing this construction, we created quadrilateral CNOQ. This is quadrilateral CNOQ. Inside this quadrilateral CNOQ, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, This 450 degree must be equal to 90 degrees in its size. So inside quadrilateral NOQC we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at its right angle in front of the square. So in relation to this quadrilateral NCOQ, it's a right angle because it has 4 right angles. But we also know that the opposite sides of a left angle are equal to each other. So in left angle NCQO, side OQ must be equal to the opposite side NC. But OQ is 5, therefore the opposite side NC must be also equal to 5 units in its length. Likewise, according to the same rule, in the same left angle NCQO, side CQ must be equal to the opposite side NO. But CQ is there, therefore the opposite side NO must be also equal to 1 unit in its length. What is the length of this line segment AN? From the drawing it is very easy to see that AN equals to AO minus NO. Again, AN equals to AO minus NO. So write it down. AN equals to AO minus NO. So AN in total equals to AO is the radius of this quarter circle, that equals to B minus NO. NO is A. So in total, AN equals to B minus A units in its length. AN equals to B minus A. So in the next step, I'll copy the right triangle A and C in the new page, and we'll implement the Pythagoras theorem of this right triangle A and C. Here by PT is the version for Pythagoras theorem. Side AN equals to B minus A, side NC equals to 5, and the hypotenuse AC is the missing side. So here, this is the right triangle A and C that according to the original drawing. This triangle A and C, according to the Pythagoras theorem, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. So write it down. This will be equation 3. AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. The hypotenuse AC is the missing side, so we leave it as it is. So it is AC squared equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared plus NC squared. NC is 5, therefore NC squared is 5 squared, that is 25. So in total, according to equation 3, we should found out that AC squared equals to B minus A squared plus 25. But according to equation 1, we have already found out that AC squared equals to X squared plus A squared. Therefore, we can substitute AC squared here by X squared plus A squared. We do it now, we get that according to equation 3, AC squared equals to x squared plus a squared, and it is equal to b minus a squared. B minus a squared equals to b squared plus a squared, b squared plus a squared, minus 2 times a times b, plus 25. So here we have a squared on both sides of the equation, so a squared gets cancelled. After we cancel a squared, in this side of the equation 3 we left only with x squared. On the other side of the equation 3 we have here b squared minus 2ab plus 25. So according to this equation 2, b squared minus 2ab equals to 25. Therefore, we substitute b squared minus 2ab here by 25. And we get that x squared in total equals to b squared minus 2ab, that is 25, plus 25. So in total, x squared equals to 25 plus 25, that is 50. So x squared equals to 50. We take out all of this equation, but before that, we take out of this equation, we get that x equals to the square root of 50. But square root 50 is 2 times 25, and the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So in total, we found out that the length of this tangent AP is equal to x. It is equal to either 5 times square root of 2 units. In terms of numbers, the length of this tangent AP that is equal to x is equal to 7.071 units. Okay, we finish with the second question. In the next step, we summarize the lecture. We start with the first question, of course. In the first question, our mission is to find out the length of this tangent MF is equal to x. We have to find out the value of x. So in the drawing, we have 3 identical circles, and we also have the big tangent ABC that is tangent to this circle at point A, is tangent to this middle circle at point B, and is tangent to this circle at point C. In addition, we have here, this is the common extent point M. For this common extent point M, we have tangent MD, that is tangent to this circle at point D. The length of tangent MD is 5 units. For the same common extent point M, we have tangent ME to this middle circle. Tangent ME is tangent to this middle circle at point E. The length of tangent ME is 7 units. And finally, we have also, this is tangent MF, that is tangent to this circle at point F. MF equals to x units in its length, and our mission is to find out the value of x. So first of all, we define the center of this circle as P, we define the center of this circle as Q, and we define the center of this circle as point S. And because of the fact that those 3 circles are identical, they must have also the same ODI. That is to say, if the radius of this circle is R, the radius of this circle must be also equal to R, and the radius of this circle must be also equal to R. So we define the radius of this circle as R. And we join points P and D together by straight line. PD is of course the radius of this circle, is equals to R. In the next step, we join points M and P together by straight line. By joining points A and P, we created the right triangle, triangle MPD. So in the next step, we implemented the Pythagoras theorem on this right triangle, triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MPD is MP, and therefore the square of the hypotenuse is MP square, and MP square must be equal to PD square plus MD square. And again, according to the Pythagoras theorem, in the right triangle MPD, MPD, MP square equals to PD square plus MD square. MP is the missing hypotenuse, so we leave it as it is. And so MP square equals to PD square. PD is out, therefore PD square is R square plus MD square. MD is 5, therefore MD square is 5 square, that is 25. So in total, according to equation 1, we can know that MP square equals to R square plus 25. We repeat it on the same process on this middle circle, that is to say we join points E and Q together by certain E. Q is of course the radius of this circle that is equal to R, and because of the fact that the radius EQ of this circle, middle circle, the radius QE of this middle circle is 1 to point E, that is the point of tendency of tangent ME with this circle, and whenever your radius is 1 to the point of tendency, then tangent MB will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and Q together by side line. By joining points M and Q, we create the right triangle MQE. So in the next step, we implemented the Pythagoras theorem on this right triangle MQE. According to the Pythagoras theorem, in this right triangle MQE, MQ square equals to QE square plus EM square. Again, according to the Pythagoras theorem, in the right triangle MQE, MQ square, that is the square of the hypotenuse, equals to QE square plus ME square. MQ is the missing hypotenuse, therefore we leave it as it is, so MQ square equals to QE square. QE is out, therefore QE square is R square plus ME square. ME is 7, therefore ME square is 7 square, that is 49. So in total, according to equation 2, we should know that MQ square equals to R square plus 49. And finally, repeated on the same process on this triangle. That is to say, we join points C and F together by side line. CF is the radius of this circle that is equal to R, and because of the fact that the radius CF is bound to point F, that is the point of tendency of tangent MF with this circle, and whenever the radius is bound to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and S together by side line. By joining points M and S, we created the right triangle MSF. In the next step, we implemented the Pythagoras theorem for this right triangle MSF. According to the Pythagoras theorem, MS squared, that is the square of the hypotenuse, equals to FS squared plus FM squared. Again, MS squared equals to SF squared plus FM squared. Okay, again, according to the Pythagoras theorem, MS squared equals to SF squared plus FM squared. MS is the missing side, so we leave it as it is. So MS squared equals to SF squared. SF is out, therefore SF squared is R squared plus MF squared. MF is X, therefore FM squared is X squared. So in total, according to the equation square, we found out that MS squared equals to R squared plus X squared. In the next step, we joined points P and A together by side line. PA is of course the radius of this circle that's equals to R, and because of the fact that the radius PA is bound to point A, that is the point of tendency of tangent ABC with this circle, and whenever your radius is bound to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points Q and B together by straight line. QB is of course the radius of this circle that is equal to R, and because of the fact that the radius QB is drawn to point B, that is the point of tendency of tangent ABC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. And finally, we join points S and C together by straight line. SC is of course the radius of this circle that is equal to R, and because of the fact that the radius SC is drawn to point C, that is the point of tendency of tangent ABC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius CQ. If ABC is perpendicular to CQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. Because of the fact that the 3 points P, Q, and S are at the same distance from the straight line ABC. While for point P, the distance of point P from the straight line ABC is PA, P equals to R. The distance of point Q from the straight line ABC is QB, QB is also R. And finally, the distance of point S from the straight line ABC is also R, because the distance is SC, and SC also equals to R. So the distance of the 3 points P, Q, and S from the straight line ABC is equal to R. They have the same distance from the other straight line ABC, and therefore they themselves must be located on one straight line. That is to say, PQS is one straight line. And because of the same reason that the 3 points P, Q, and S are located at the same distance from the other straight line ABC, therefore the straight line PQS must be parallel to the straight line ABC. Again, because of the fact that the 3 points P, Q, and S are at the same distance from the straight line ABC, it means that the straight line PQS must be parallel to the straight line ABC. Okay? And because of the fact that the straight line PQS is parallel to the straight line ABC, you can implement here rule 17. So I repeat quickly rule 17. According to rule 17, the sum of one-sided interior angles between two parallel lines is equal to 180 degrees. So in the drawing we have line AB, that is line A that is parallel to line B. We also have the red line C that cuts the two parallel lines A and B at those points, and those two angles, 2 and 1, are defined as one-sided interior angles. They are one-sided because of the fact that they are located on the same side of the straight line C. They are both located on the right side of the red line C. For that reason, they are one-sided. And they are also interior angles because of the fact that both of those two angles, 2 and 1, are located between the parallel lines A and B. So in total, those two angles, 2 and 1, they are defined as one-sided interior angles. And according to this rule 1, the sum of two one-sided interior angles is equal to 180 degrees. That is to say, angle 2 plus angle 1 is equal to 180 degrees. Likewise, those two angles alpha and beta, they are also defined as one-sided interior angles. And according to this rule 17, the sum of two one-sided interior angles is equal to 180 degrees. That is to say, angle alpha plus angle beta is equal to 180 degrees. So we can actually implement rule 17 in our drawing. Why? Because in our drawing we have, somebody mentioned before, PQS, the straight line PQS is parallel to the straight line ABC. And those two angles are defined as one-sided interior angles. And according to rule 17, the sum of two one-sided interior angles is equal to 180 degrees. So the sum of those two angles must be equal to 180 degrees according to rule 17. But this is a right angle. So that is to say it is equal to 90 degrees in its side. So 90 degrees plus this missing angle in total, they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its sides. Likewise, those two angles are also defined as one-sided interangles. And according to rule 17, the sum of two one-sided interangles is equal to 180 degrees. So this angle equals to 90 degrees plus this missing angle in total must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its sides. Those two angles are also defined as one-sided interangles. This is the right angle plus this missing angle in total must be equal to 180 degrees. Therefore, the missing angle here, this missing angle here must be equal to 90 degrees in its sides. And finally, those two angles are also defined as one-sided interangles. This is the right angle plus this missing angle in total must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. So inside quadrangle QSCB we have four right angles, and according to rule 5, any quadrangle that has four right angles must be this rectangle if not a square. So in order to this quadrangle QSCB is a rectangle because it has four right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC is free, therefore QS, the opposite side QS must be also equal to 3 units in its length. Likewise, inside this quadrangle PQBA we have four right angles, and according to rule 5, any quadrangle that has four right angles must be this rectangle if not a square. So to this quadrangle PQBA is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle PQBA, side AB must be equal to the opposite side PQ. But AB is 3 according to what is given as the question. Therefore, PQ must be also equal to 3 units in its length. In the next step, I copied the big triangle PMS in the new page, and we analyze this big triangle PMS. We just later on found out that PQ equals to 3 units in its length, and QS also equals to 3 units in its length. So actually, this is triangle PMS at the copied from the original drawing. This is line segment MQ. So, in triangle PMS, we have line segment MQ. Line segment MQ is defined as a median of triangle PMS. My line segment MQ is the median of this triangle PMS because of the fact that line segment MQ starts from the vertex M and ends at point Q, that is the midpoint of the opposite side PS. Why point Q is the midpoint of the opposite side PS? Because of the fact that at point Q, side PS has been bisected into two halves. The first half is PQ, that is 3 units, and the second half is QS, that is also 3 units. So the median of a triangle bisects the opposite side to the vertex. Okay, the median MQ bisects side PS into two halves. Each half equals to 3 units in its length. But the question is, what is the length of this median MQ? Actually, we have a special formula to calculate the length of the median MQ. So here we have what is the length of a median in a triangle. Here we have triangle ABC. The length of side AB is B units, side AC equals to 3 units in its length, and side BC of this triangle ABC equals to A units in its length. AD is defined as the median of this triangle ABC. Why? Because of the fact that line segment AD starts from point A, that is vertex of this triangle ABC, and ends at the opposite side of vertex A. The opposite side of vertex A is side BC. So, and the median AD bisects side BC. That is to say, the median AD divides side BC into two halves. Each half equals to BC over 2. So BD equals to BC over 2 and DC equals to BC over 2. So BD equals to DC. So the median AD bisects side BC into two halves. So what is the length of the median AD? According to the formula, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. AB equals to B units in itself, AC equals to C units in itself, and BC equals to A units in itself. And the length of the median AD is equals to the square root of 2b squared plus 2c squared minus a squared over 2. So actually implement the new formula in order to find out the length of the median MQ. The length of the median MQ in triangle PMS will be equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. Okay, again MQ equals to the square root of 2 times MP squared plus 2MS squared plus minus PS squared over 2. Here we multiply this equation 1 by 2, and finally found out that 2 times MS equals to the square root of 2MP squared plus 2MS squared minus PS squared. Here we squared both sides of this equation 1. So 2MQ squared is 2 squared, that is 4, times MQ squared. So in total 2MQ squared is 4MQ squared. And because of the fact that the root and the square of two opposite operations, when we square the root will be cancelled, and we're left only with 2MP squared plus 2MS squared minus PS squared. So in total, according to equation 1, we found out that 4 times MQ squared equals to 2MP squared plus 2MS squared minus PS squared. So 4 times MQ squared. According to equation 2, MQ squared equals to R squared plus 49. Therefore, we substitute MQ squared here by R squared plus 49, and it is equal to 2MP squared. But according to equation 1, MP squared equals to R squared plus 25. Therefore, we substitute MP squared here by R squared plus 25. So 2MP squared in total it is 2 times R squared plus 25 plus 2MS squared. MS squared, according to equation 3, MS squared equals to R squared plus X squared. Therefore, we can substitute MS squared in this equation by R squared plus X squared. So in total 2MS squared is 2 times R squared plus X squared. We have here minus PS squared. PS in total is 3 plus 3, that is 6. Therefore PS squared is 6 squared, that is 36. Again, PS squared in total is 36. So it is minus PS squared is minus 36. Here we open the brackets on both sides of this equation 1, and found out that 4 times R squared equals to 4 times R squared plus 4 times 49. 4 times 49 is 196, and it is equal to 2R squared plus 2 times 25, that is 50. And we have here also 2 times R squared plus 2 times X squared minus 36. So in this on this equation 1 we have 4R squared. In the other side of the equation we have 2R squared plus 2R squared, that is 4R squared. So 4R squared will get cancelled. After we cancel 4R squared, in the side of the equation 1 we left only with 196. On the other side of the equation 1 we have 50 minus 36, that is 14. So in total, in this side of equation 1 we have 14 plus 2x squared. So according to equation 1, we found out that 196 equals to 14 plus 2x squared. Here we divided this equation 1 by 2, and finally found out that actually we subtracted 14 from this equation, and found out that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divided this equation 1 by 2, and finally found out that 182 over 2 is 91, so x squared equals to 91. Here we took a root out of this equation and finally found out that x equals to the square root of 91. The square root of 91 is 9.54 units. So in total we found out that the length of this tangent MF that is equal to x is equal to either the square root of 91 units, or in terms of numbers, the length of tangent MF that is equal to x is equal to 9.54 units. So we finish with the first question. In the next step, I present the second question and solve the second question of this lecture. So Our mission in the second question is to find out the graph of this standard AP is equal to x. We have to find out the value of x. So in the drawing we have a quarter circle A or B, and we have also this small circle that is located inside the quarter circle, and they touch each other internally at point K. This point, this is their touching point. Again, our mission is to find out the graph of standard AP is equal to x. So first of all, we define the center of this small circle. This point is point C, and we join point C and Q together by straight line. CQ is of course the radius of this small circle. We define the radius of this small circle CQ as A. We define the radius of the big quarter circle as B. And we also join point C and P together by straight line. CP is of course the radius of this small circle that is A. And because of the fact that the radius CP is known to point P, that is the point of tendency of tangent AP with this small circle, and whenever radius is known to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. Here also, because of the fact that the radius CQ is known to point Q, that is the point of tendency of tangent OB with this small circle, and whenever your radius is known to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. In the next step, we join points A and C together by straight line. By joining points A and C, we get the right triangle APC. So in the next step, I copy the right triangle APC in a new page and implemented the Pythagoras theorem on this right triangle APC. This is the right triangle APC that is covered from the original drawing. According to the Pythagoras theorem, this right triangle APC, AC squared equals to AP squared plus PC squared. AC is the missing side, so we leave it as it is. So AC squared equals to AP squared. AP is x, therefore AP squared is x squared plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we can find out that AC squared equals to x squared plus a squared. Because of the fact that the big quarter circle and the small circle have an internal length between them at point K, we can implement a rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. So in the drawing we have two circles. The center of this big circle is at point O. The center of this small circle is at point M. The straight line that connects their centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass for their touching point, that is point P. Again, the straight line OM must pass for point P, that is their touching point. OMP is one straight line. Again, OMP is one straight line according to this rule 9. We can actually implement rule 9 in our drawing. In our drawing, we have an internal length between the big quarter circle and the small circle, that is to say they touch each other at point K. The center of this big quarter circle is at point O. The center of this small circle is at point C. The straight line that connects the centers together is the straight line OC. And according to rule 9, the straight line OC must pass for the touching point, that is point K, or OCK is one straight line. So we join points R and C together by straight line, and when we extended OC, the extended line segment OC touches point K, exactly according to rule 9. OCK is one straight line. So in the next step, I call it the right triangle OCK in a new page, and implemented the Pythagoras theorem on this right triangle OCK. But before that, CK is the radius of this small circle that is A, OK is the radius of the big quarter circle that is B. So in total, OC equals to OK minus CK. Again, OC equals to OK minus CK. OK is B, CK is A, so in total OC equals to B minus A, CQ equals to A, and OQ equals to 5 minutes in length according to what is given in the question. So in the next step, I copied the right triangle OCQ in the new page and implemented the Pythagoras theorem on this right triangle OCQ. So this is the right triangle OCQ that I copied from the original drawing. In this right triangle OCQ, OC squared equals to CQ squared, OC squared equals to CQ squared plus QO squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equals to CQ squared. CQ is A, therefore CQ squared is A squared, plus OQ square. OQ is 5, therefore OQ square is 5 square, that is 25. So in total, according to equation 2, I should found out that B minus A square equals to A square plus 25. B minus A square is B square plus A square minus 2AB, and it is equal to A square plus 25. Here we have A square on both sides of the equation, so A square will get cancelled. After I cancelled A square, on this side of the equation we left only with B square, and the other side of the we left only with B square minus 2AB, and on the other side of the equation we left only with 25. So in total, according to equation 2, I should found out that B square minus 2AB equals to 25. In the next step, we did the construction, that is to say from point C we draw perpendicular on AO. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO, this point is point N. By doing this construction, we create quadrilateral NCOQ. Inside this quadrilateral NCOQ we have 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the side of this 4 pieces again, in total it must be equal to 360 degrees according to the rule that states that the sum of the angles in every quadrilateral is equal to 360 degrees. Therefore this 4 pieces again must be equal to 90 degrees in its size. So inside quadrilateral NCQO we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be a right angle across the square. So we learn to this quadrilateral NCQO is a right angle because it has 4 right angles. But you also know that the opposite sides of a right angle are equal to each other. So left angle NCQO, side NC must be equal to the opposite side OQ, but OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the sum rule, in the same left angle NCQO, side CQ must be equal to the opposite side NO, but CQ is there, therefore NO must be also equal to A units in its length. What is the length of the missing line segment AN? AN equals to AO minus NO. So AN equals to AO minus NO. AO is B, is the radius of the quarter second, minus ON. ON is A. So in total, AN equals to B minus A units in its length. NC equals to 5. AC is the missing side. So in the next step, I call it the right triangle ANC in an page and implemented the Pythagoras theorem. This right triangle ANC. This is the right triangle ANC, the comic of the original drawing, according to the Pythagoras theorem. In this right triangle ANC, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. AC is the missing side, so we leave it as it is. So it is AC squared equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared plus NC squared. NC is 5, therefore NC squared is 5 squared, that is 25. So in total, according to equation 2, I should found out, according to equation 3, I should found out that AC squared equals to B minus A squared plus 25. So AC squared equals to B, according to equation 1, AC squared equals to X squared plus A squared. Therefore, we substitute AC squared here by X squared plus A squared, and it is equals to B minus A squared. B minus A squared equals to B squared plus A squared minus 2 times AB plus 25. Here we have A squared on both sides of the equation, so A squared will cancel, so we cancel A squared. On this side of the equation we have to leave with X squared, and the other side of the equation we have B squared minus 2AB plus 25. But according to equation 2, B squared minus 2AB is 25. Therefore, we can substitute B squared minus 2AB by 25. Here we did it, and we can find out that X squared equals to here B squared minus 2AB is 25. So in total, in this side of the equation we have 25 plus 25, that is 50. So in total we should find out that X squared equals to 50. Here we took out of this equation and found out that X equals to the square root of 50. 50 is 2 times 25. So the square root of 2 times 25 is the square root of 25 is 5. So in total this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So in total we should find out that the length of this line segment AP is equal to X. It is equal to either 5 times square root of 2 units. In terms of numbers, the length of tangent AP is equal to X. It is equal to 7.071 units in its length. Okay, thank you very much.